Question says, in addition to carbon monoxide, CO, and carbon dioxide, CO2, there is a third compound of carbon and oxygen called carbon suboxide, full stop. If 2.500 grams sample of carbon suboxide contains 1.2 grams of carbon and 1.18 grams of oxygen, what is the possible formula for carbon suboxide? Who is done solving? You're done solving. You're done solving. Wow. So tell me, what's the idea behind this? What do you do? If you have to find formula, which concept comes to your mind? Empirical word there, molecular formula. That's it. So I'm giving you a thought process now. I was in the exam hall now, and I see this question. What would I do? The question says, what is the formula? When it comes to finding formula, the key thing that comes to mind is empirical and molecular formula. If I'm to do empirical formula, what exactly do I do? It depends on the question. In some question that relates to empirical formula, if you know how it works, they'll give you percentage composition, right? Yes, they'll give you percentage composition of what there? Each of the elements there. So my class will now be, can I find percentage composition here? Is it possible? Is it possible for me to find percentage composition here? For percentage composition, oh, my throat is dry. For percentage composition, what's the formula? If I'm going to get the, take down. Recall that, take down please. Recall that the percentage composition of an element in a compound is given by, recall that the percentage composition of an element in a compound is given by, so percentage composition is given by mass of elements all over, you can say molar mass of compound times 100%. So mass of elements or molar mass of compound or whatever. Please check please. In this stuff, in this particular compound, we know is carbon suboxide, which we know it should contain what and what there? Carbon and what there? Oxygen. So let's start with the first one. For carbon, it's equal to percentage composition is equal to, please check, what's the mass of carbon there as given? Sorry? 4.32. 1.32. Please check, what was the mass of the compound there? 2.50 times how many there? Times 100. Please give me the final answer, please. Please punch correctly, please. Sorry? 52.8%. Okay. Let's take for oxygen. It becomes, please check your mass of oxygen there. The element now is oxygen. Check. 1.18 all over mass of the compound times 100%. Please give me final answer. Sorry? 47.2%. So I have this. 47.2%. If I have this one now, I can now start doing empirical formula. So we say for empirical formula, simply list out the elements that composes the compound. That's carbon and oxygen. Your first task, write out their percentage composition, 52.8 for carbon, for oxygen, 47.2. Second task, divide both of them by what there? The atomic mass. For carbon, how many? By 12. For oxygen, how many there? Please help me punch. Please, I hope you know what I'm doing. Because this is empirical formula. I'm not teaching this. You know what to do. Please divide this, please. Give me an answer, please. 4 points. It's advisable, if possible, to leave it in as many decimal places as possible. If possible, give me in 2dp. What do you have? 4.40. Okay. This man, 2.95. If I divide by their atomic masses, I now have these ones here. What's the next task there? Let me write it there. Divide by the smallest value. My smallest value here is 2.95, so it becomes 4.40 all over 2.95 into 2.95 all over 2.95. Please help me out. This will give you 1. What do you have here? 1.49. Abby? 1.49. What did you hear? What did you hear? Multiply by 2. We say multiply by 2. You should know why we're multiplying by 2, right? This one is not a whole number, and 1.5 is still not a whole number, right? If I look up please, 1.49. If I presume this becomes what there? Okay, let's just use for 1.49 per se, but this should be 1.5. I have to multiply by 2. Why? If I multiply this one by 2, I'm expecting what there? 3, a whole number. That's why I'm multiplying by 2. I've done a video on empirical formula. Please go and check it, please. Right? In some cases, you multiply by 2. Some cases, you convert to the nearest whole number, Abby? Yes. So please go and check out that video, please. For this one here, I'll multiply by 2. Multiply this by 2, what do you have there? 2.98. And that's what I'm saying. This one to the nearest whole number. Let's use 1.5, please. So to give me 3 at once. So don't start going about the bush. So this one here, 4.9 is approximately 1.5. Multiply by 2, I have what there? 3 and then 2. So therefore, the formula of carbon suboxide is C3O2. All right. So that's the answer, please. Answer is C3O2. We'll do this B and go on break. Is that okay? Or should we go on break? Okay, let's do a deal. I won't solve all. This one says write the Lewis dot structure of about 5 compounds here. Write Lewis dot structure. I'll do only 2, you go do 3. Or I'll do only 1, you go do 4. Alright, 1B. Write the Lewis dot structure. Please pass question. Write the Lewis dot structure. Write the Lewis dot structure for H2CO3, NO2. I think there's a minus here. 3. This stuff are so tiny. I'm not sure there's a dot. It's just so tiny. But let's just hope that what I'm having here is NO plus. 4 NCl3, 5 H3BO3. All right. What is the structure for this? Again, it says an engineering student accidentally spills 1.00 dm cube bottle of concentrated 18.0 mole per dm cube of pure sulfuric acid in brackets H2SO4 on the floor of our laboratory. Full stop. He attempts to neutralize the spill by pouring a 5.00 kilogram box of baking powder, also called sodium hydrogen carbonate, NaHCO3, onto the floor. A says write a balanced chemical equation of the reaction. For that reaction, please, what are the reactants? H2SO4 combining with what there? NaHCO3. They gave you a hint. They said it will produce a salt. Please, what salt, please? Na2SO4. Sodium is +1. Abi? SO4 is what there? 2 minus. Please be careful. Sodium is +1. SO4 is 2 minus. The 2 will come here and 1. So it's this. Plus, they said also carbon dioxide, CO2, and then water, so H2O. So I have this. Please, they said write a balanced chemical equation. Please, who's balancing for us, please? What do you have, please? Here? 1. Okay, here? So I'm having 2 sodium here, 2 here to make it 2 sodium, 2 sodium. Okay, what's here? 1. What's here? 2. Anything here? 2. Hold on now, hold on. Remove 2 from CO2. Please check. Oh, someone told me this. Is it balanced? What's balanced? Tell us what you have there, please. Na2SO4 plus 2H2O plus 2. It's the same thing now. Hydrogen, I have 2 here. I have 2 times 1 here, 2. In total, 4 hydrogen. Here, 2 times 2, 4 hydrogen. Settled. Sulfur, I have just 1 here. In all of this, I have just 1. Settled. Oxygen, I have 4 here. I have 2 times 3. That's 6. 6 plus 4, that's 10. Here I have 4. 2 times 1, that's 2. 4 plus 2, 6. 2 times 2, 4. 4 plus 6, 10. That's balanced. Sodium, I have 2 times 1, 2. Here I have 2. That's balanced. I've dealt with hydrogen. So it's, yes, it's balanced. So the A part settled. A part says, write a balanced chemical equation for the reaction. That part settled. B says, what is the limiting reagent? What is the limiting reagent? All right. Concept of limiting reagent. We said in each of the cases, I expect that my attention should be drawn to 2 things, which, as we've done in our previous example, they will always mention the 2. But this one is now asking you what is the limiting reagent without mentioning any two. Why is it so? Because the concept of limiting reagent and excess reagent only works for what there? Reactant. It doesn't involve product. The calculation for product is what there? Actual yield, theoretical yield, and what there? Percentage yield. So when they ask you for limiting reagent, it's called a reagent. The term reagent also means what there? Reactant. They're the same thing. In other words, for this equation here, if I'm to find limiting reagent, I won't consider these ones. These are products. For limiting reagents, I will take these 2 because they're the reactants. So that's your first task. So you can take them, please. For limiting reagents, we consider only the reactants. That is H2SO4 and NaHCO3. Please, the reactant is only the reagents, only reactants, right? For limiting reagents or for reagents, we only consider the reactants. I point E, that is H2SO4 and NaHCO3. That's it. Full stop. From the balanced equation of the reaction, From the balanced equation of the reaction, two moles of NaHCO3 from the balanced equation of the reaction, 2 moles of NaHCO3. So no one to use 2 as a mole and as a volume. No one to use it. 2 moles of NaHCO3 are required to neutralize 1 mole of H2SO4. 2 moles of NaHCO3 are required to neutralize H2SO4. Hence, H2SO4 NaHCO3. So you know how we do this. This is 1, this is 2. So I have this. So the first one is settled. So you know how this thing works. We know that I need a kind of mole. The first mole is always equal to the mole from a balanced equation. The second mole is something you can infer from your question. Please check in your question. Were you given the mole of the acid H2SO4? Check. Check. Were you given the mole of this man here? Were you given the mole or the molarity? Please be careful. By the way, check for this one here, the carbonate. Were you given the mole? What were you given? The mass. So hold on. This one here, I was giving molarity. I know that molarity M is equal to mole all over what there? Volume. That means even though I'm giving molarity, I can find the mole. How? Multiply molarity by volume. Please, were you giving volume there? So problem solved. We can get mole. Also, for NaHCO3, I was given mass. If I'm given mass, I know I can still find mole. How? I know that mole is equal to what there? Mass over molar mass. So here's my task. First of all, get the mole of the acid by multiplying its molarity by volume. That's task 1. Task 2, try to get the molar mass of the carbonates there, such that you can divide the mass by molar mass to get mole. So you now see my 2 tasks there. So take down, please. Take down. From the question, sorry, I'm giving this kind of long note, but I'm giving this kind of note so that when you're studying the notes, you can understand it. All right. Note is plenty, right? Good. That's how your exam sheets will be plenty. From the question, comma, to get the mole, from the question, to get the mole, but honestly, you can just go and do this and publish it as a handout. It's very comprehensive, right? Go and do a handout. To get the mole of the acid, take down. To get the mole of the acid, recall that molarity is equal to mole over volume. So you have that mole is equal to molarity times volume. That's equal to molarity. Please give me that molarity again. Please, before you do your time volume, please check. Are they in the same unit? DMQ? Yes. Okay, so you can proceed. Molarity, please give me value. 18.0 times volume 1. So what's the mole there? Becomes 18 moles of what there? Of the acid H2SO4. Keep it pending. Next up, let's get mole for this. Take down, please. Also, to get the number of moles for the base, sorry, that's a base, sorry. Also, to get the number of moles of NaHCO3, that's the carbonate. Also, to get the number of moles of this one here, recall something. Recall that, what's the formula again there? Mole is equal to mass all over molar mass. So the mass, how many again, please? How many? 5 kilograms. Please, I work with kilograms or grams. So convert to grams. What do you do? Becomes 5,000 grams. 5,000 is 5 times 1,000. A kilo is 1,000. So it becomes 5,000 grams. Let's do molar mass. Molar mass of NaHCO3. For sodium, what's the atomic mass? 23. Plus for hydrogen 1, plus for carbon 12, plus for oxygen 16 times how many atoms there? 3. So I have this. Please sum this up and give me final answer, please. Sorry? I'm not 50, I'm 80. 84. That's 84 gram per mole. Okay, so what's up? So it means that mole of NaHCO3 is equal to the mass of it. What's the mass again? 5,000. So 5,000 all over 84. Please give me value. 59.5 what there? 52 moles of Chief Leno. You're doing Leno. Alright, so I have this, please. Alright. If you're here, let me explain something, please. If you're here, let me explain something, please. In your final year, you'll be doing mechanical marine. In your final year, you still be doing these stuffs. Because you now come back to chemistry in final year, basic chemistry. When you're learning about materials, chemistry of materials, this one here. Now you analyze plastic. So they will say they want to build a bulletproof car or something like that. They will say which material should be used. You analyze this stuff using chemistry. So all this you're seeing here is not a waste. Now listen up. Listen up. Listen up. Listen up. Chief, you tell me that I don't understand what I'm saying. Listen up. So here's what's up. First things first, we got a balanced equation for this. Next up, my moles were this and this. Next up, we looked at the question, and from our question, we were able to get another kind of mole, in which for this one here, the acid, we got the moles as 18 moles of the acid H2SO4. We also got this as 59.52 moles of the carbonate, that's NaHCO3. They are saying that one of these is a limiting reagent. So the question is this: which of them exactly is the limiting reagent? Is it this one here or this one here? How do we know? Take down. Now listen. I won't say there is a direct way of getting limiting reagents. I won't say so. It's something that, look up, you do something and then you infer. What do I mean? Aside the 1 and 2, I now have 18 and 59.52. You call one of them X and then solve. So let's say, since this man is a whole number, please, you can use any one you want to. We still have the same thing. Take this, please. Look up, please. Take this, please. Let the number of moles, take that, please. Let the number of moles of NaHCO3, let the number of moles of NaHCO3, let the number of moles of NaHCO3 required to react with 18 moles of H2SO4 be X. Let the number of moles of NaHCO3 required to react with 18 moles of H2SO4 be X. Hence, we now have this. So please, can now copy this one down, please. So hence, we now have this one here. So please know what I did, please. I already know the move for this, but let's assume we didn't know. Let's get the answer. Obviously here, I'll have to cross multiply. So from here, if I cross multiply this and this, X times 1, I have X times 1 is equal to 2 times 18. So X times 1, X, 2 times 18, 36 moles. All right. Take down, please. Take down, please. If you're here, take down. Hence, if you're here, take down, please. Hence is a chemistry language. So in chemistry, we putting hence there is a language. If it's in physics, you use hence. So, but the major word there's always recall formulas. In physics, chemistry is hence. So use the hence for them. Is that an alternative? Huh? A synonym? However, that's literally in English. No, that's English. That's not. How many times you see however in chemistry textbook? However in chemistry textbook, it's rare. Therefore is the final answer. That's why I know therefore. Therefore is fine. When you've done the whole thing there, you now say therefore, you end it. Since take that, please. Take that, please. So let me use your since. No. Since is continuous, it's hence. So listen to this now. So I'll not say so. Please, hence, please. Hence, 36 moles. Hence, 36 moles of NaHCO3. Hence, 36 moles of NaHCO3. Hence, 36 moles of NaHCO3 is required, full stop, just stop there, let me go mention it. Hence, 36 moles of NaHCO3 is required, full stop. At this point, you can now see the limiting and the excess. Listen, what's a limiting reagent? A limiting reagent is simply the reagent that is what there first used up in a chemical reaction. The excess is the one that's what there remaining after the reaction has stopped. So look up, please. Here's now the idea. In this one, I got 18 moles. What I actually need to neutralize this 18 moles of the acid is only 36 moles of this. But from our calculation, we have what there? 59.52 moles. What does it tell you? This much what there in excess. What it tells you. That's the concept. So we've gotten this two already there, but I said assume this one to be unknown, so X. Let's look for the actual value of this carbonate that will react to neutralize the acid. The acid was 18. When we did our calculation, we saw that we needed only 36 moles. But then, in this 36 moles there, the actual value of this one is actually 59. So I have 59, I need 36. That means this one is in excess. So take down, please. Take down. Since only 36 moles of NaHCO3 are required, since only 36 moles of NaHCO3 are required, and we have 59.52 moles, since 36 moles of NaHCO3 are required, and we have 59.52 moles of this of NaHCO3, comma, then so we can know that this one is the excess. Then NaHCO3 is the excess reagent, and H2SO4 is the limiting reagent. So that's it. So hence, this one becomes the excess because I have more than the required 36. This one becomes the limiting. So one will be excess, the other limiting. So at this point, you can now say therefore, since you're done. Therefore, the limiting reagent is H2SO4. Yes. You'll be doing Chempet petroleum. This is your thing. You'll be doing chemistry. It's your thing. Chempet petroleum. Go and just kill yourself with chemistry. Because it's your thing. It's your thing. This is only question. This is only 1B. We have 1 to E. 1C, let's proceed. 1C, take down. 1C, how many grams, 1C, how many grams of sodium hydrogen carbonates, how many grams of sodium hydrogen carbonates, how many grams of sodium hydrogen carbonates are required to neutralize all the acids? How many grams of sodium hydrogen carbonates are required to neutralize all the acids? So please check. All the acid I had was how many moles? 18. Abby? Take down, please. Take down, please. All the acids have 18 moles, comma, have 18 moles, comma, and the number of the moles of NaHCO3 and the number of the moles of NaHCO3 required to neutralize it is how many, please? Check. Is equal to 36 moles. We are asked to find the mass in grams. So convert 36 moles to mass in grams. What do you do? So recall that mole is equal to what there? Mass all over molar mass. So we said we can get the mass by saying what there? Mass of NaHCO3 is equal to what there? Mole times molar mass. Of course, this times 1 mole mass is equal to mole times this. So that's equal to, the mole is 36 times, please, what's the molar mass? How many? We calculated that as 84. So please give me value. 803024 grams of NaHCO3. Alright, so that's it. So we just simply converted that mole that we got to mass in grams. That's it. 1D, see on that one. I wonder why people don't emphasize the concept of being strong mentally and physically in exam. They don't look at that part. It's just go and read. People don't emphasize the importance of a good handwriting exam. They don't look at that one. It's always go and read. So this is the matter. It's a matter. Let's not go there, Sha. Not go there. Don't worry. D. How many moles of excess reagent? How many moles of excess reagent remains? How many moles of excess reagent remains after all the limiting reagent has been consumed? Again, how many moles of the excess reagent remains after all the limiting reagent has been consumed? How many moles of the excess reagent remains after all the limiting reagent has been consumed? Alright, so look up. Let's answer that question, please. It's a simple question. They're asking you how many moles of the excess reagent will be remaining after all the moles of the limiting has been consumed. Look up, please. Go to your excess reagent, which was how many? That was this man there. It was 59.52 moles. This is the excess value. Now the question is this: when the limiting reagent, which is this one here, and this was 18, when 18 moles of this has been consumed, these 18 moles of H2SO4 will take away how many from here? We take away 36. So it becomes this one here minus what there? 36. That's all. The excess value minus this one. This is the value of the moles of the carbonate that will go away with this one. So how many is remaining? Please subtract this one you have. Sorry? 52 moles. That's 1D. 1E. 1E. E, take down. With a floor, I said, with a floor consisting of bare concrete in brackets, that is calcium carbonate, require more, less, or the same amount. Require more, less, or the same amount of. Require more, less, or the same amount of sodium hydrogen carbonate. To neutralize the spill. Question mark. Now here's the question. It says, if that ground is made up of what there? Concrete. Concrete in brackets is calcium carbonate. Here's what's important to note. What's important to note is this: that acid reacts with what there? Carbonate. So if that floor was made up of calcium carbonate, would I require more of this less of this or the same amount to neutralize it, I'll require less amount. Why less? Answer is simple. Because if the acid is on the floor and I have the carbonates there, that carbonate will do what there? Neutralize some of the acid. And hence, the number of moles of the acid will do what there? Reduce. And hence, I'll now require less of this. Take that please. Less. Answer less. Answer less. Less amount. Answer less amount. Reason. Let me give you a reason. Answer less amount. Reason less amount. Because the floor being made up of carbonates. Now see the way I'm presenting the work for them. So nice. Because the floor being made up of calcium carbonates would react with the acid, thereby decreasing the number of moles of the acid. Would react with the acid, therefore reducing the number of moles of the acid. Hence, a lesser, what's the word there? Hence, a lesser, the word there is amount. So, hence, a lesser amount of NaHCO3 will be required. I've told you why. Hence, a lesser amount of NaHCO3 will be required. Full stop. So, gents and gentlemen, we've answered question 1 and question 2. Let's do question 3. Just so I'm coming, please. Question. Germanium has 3 major naturally occurring isotopes. Ge70, that's this one here. Then Ge72, this one here. And Ge74, this one here. It says there are 2 minor isotopes, germanium 73, this one here, and germanium 76, this one here. Given that the relative atomic mass of germanium in the periodic table is 72.64 AMU. What's AMU? Atomic mass unit. What is the equivalent of an AMU? Gram per mole. Gram per mole. Gram per mole. Right? It's just as saying molar mass in gram per mole. Atomic mass in AMU. Atomic mass units. So AMU and gram per mole, they mean almost the same thing, please. All right. What are the natural abundances of the 2 minor isotopes? How do you solve this question? Remember that atomic mass is equal to what there? The sum of what? Product of what there? Isotopic mass and what there? Percentage abundance. Please, I have a full tutorial on this stuff, please. Check it out, please. This is your formula. That atomic mass is equal to, this one means sum, the sum of the isotopic masses, the AMU, times the percentage abundances for each of the isotopes, of course. So look up, please. This one here is quite technical. In other, listen. In other examples, they'll say, given that the atomic mass and percentage abundances of the isotopes of germanium are 1, 2, 3. Find the atomic mass of germanium. It simply becomes this one here times this man is in percent. So I'll divide by 100, becomes 0.2 whatever. So it becomes this times this plus this times this in decimal plus this times this and then sum them. That's how it's done. But in this case now, this one is now a bit technical. Look up, please. Who has done the example where the natural abundance is not given? What has done that kind of example for? when you now have x and x minus 1. What have you done before? If you've not done it, how do I relate this to you now? But I've sent a video on that before now. That's why this is supposed to be a revision class. There's no time. Okay, I'll just look up now. I'll just go on and solve this because of time. I'll just go on and solve this. Take down, please. Let me show you how this is done. Please, I will send you a video on this thing, please. Right, you see the full. Please try to follow it up, please. My channel is start loaded. Some of you are not following. If you follow the channel, trust me, you're good to go. Trust me, you're good to go. Like, don't even just follow the channel side. You're just good to go. Or you don't have data. Give away. What data? Okay, so give away. I'll do a 3K giveaway. Fastest fingers on the group. It's late. From here, I'm going to sleep so I can shout and cheer Manchester City in the evening. So tomorrow, expect it tomorrow. Oh, tomorrow is Sunday. Monday. Oh, Monday is even your exam. It says. All right, it's okay. Take that, please. Let me try to solve this one, please. Just listen to what I'm saying, please. When you go back, refer to the video and then come back to this. You understand it perfectly, please. Take down, please. Let's solve this one. Take down. Take down, please. The percentage abundance in bracket relative abundance is the same thing, either called a percentage abundance or a relative abundance. The percentage abundance in bracket or relative abundance for each isotopes. Okay, hold on. Or relative abundance for germanium 70, germanium 72 and germanium 74 are these. The percentage abundance of germanium 70, 72 and 74 are 20.85%, 27.54% and 36.29% respectively, and 36.29% respectively. Just follow me up. In decimal, it's equal to, convert to decimal. 20.85% becomes what there? 0.2085. How? Divided by 100. Of course, 2% is 2 over 100. That's the concept. Divide the next one by 100 gives you 0.2754 and 0.3629 respectively. In decimals are 1, 2, and 3 respectively. Full stop. Let the percentage abundances of the minor isotope germanium 73 and germanium 76 be X and Y. Let's call it X and Y. Like we don't know, because we don't know, we want to assume. So use two variables, X and Y. You can say respectively respectively. Full stop. Also recall that the sum of all fractional abundances in decimal also recall that the sum of all fractional abundances in decimals for the isotope of an element is equal to 1. Also recall that the sum of the fractional abundances of all the isotope of an element in decimal is equal to 1. Hence, this one here, 0.2085 plus this one here, 0.2754 plus this one here, 0.3629 plus, so these are the ones for the major. Now include the minor. The first minor only was x, so plus x plus this one here, y, is equal to 1. Please, this concept is crucial. I wonder why you said you've not done this before now. You should have. The idea is this: if I sum the percentage abundances, it should give me 1. That's the idea. Please give me this. What do you have? Please, these three. How many? 8, 4, 6, 8 plus x plus y is equal to 1. So you have this. What's x plus y? X plus y is equal to 1 minus this one here, 0.84684. What's the value, please? 0.15. That's 32 now. 8. Thank you. And then 0. This. So if you are done, so if you had assumed that you've prepared for chemistry exam, and up to now these things are looking strange, do you actually think you prepared? Because these are actually past questions. So you know what I said. So when I said there are certain funny questions, the one that lady was showing me, she was showing part. Look at it, that part was from 2005, and the question there was simply draw the Lewis structure for fluorine like this. That's all. We will send this for you again now today. So look up, please. So it means that x plus y is equal to how many there? Now listen. If you're good with your maths, you should know that we cannot find the value of two variables with just one equation. True? If I have two separate equations, I need at least two different equations such that I will solve them there simultaneously. And that's how you have the concept of simultaneous equation. But in this case here, I cannot form a simultaneous equation. So what do? Idea is simple. I will express one variable in terms of another variable. It's a simple mathematical concept. What does it mean here? It means that express y in terms of x. What's y here? Y is equal to what there? 0.1532 minus x. So listen. It means that for germanium 70, the atomic mass is this, the relative abundance is this. For 72, atomic mass is this, relative abundance is this. For 74, atomic mass is this, Relative abundance is this. For 73, atomic mass is this one here. Relative abundance is X. Check, we said so. Let it be X. Is X. For germanium 76, relative abundance becomes what there? 0. Hold on, it's Y, but we can't use Y to do so. Two different variables. So use what there? X. So it becomes what there? 0.15232 minus X. Alright, so at this point, we are halfway done. Let's now do the major thing. Yes. Please, I can't hear you. Talk to me, let me hear you. For this one, yes. Yes, for this one. Alright. Take down, please. Take down, please. Therefore, so listen, please. Listen, please. Check your formula. The formula was this, that the atomic mass was equal to the sum of the product of isotopic mass and what there? Percentage abundance or fractional abundance or relative abundance. So look up, please. So look up. Please check your question. What was the atomic mass? All right. So it means that 72 point how many? 64 is equal to, let's start with germanium 70. For germanium 70, please check. What was the mass there? Check. 69? 69? So 69.92425 times, what was the fractional abundance in terms of decimal? 0.22085. This is for germanium 70 plus, we said we're taking the total sum. Let's take for 71, for 72, please. Where's the mass here? Times how many? Let's take for the next one, this one here. The next one was germanium 74. How many? Where was the decimal there? 0 point. Plus, let's now go to the minor isotope. For the minor, we have this one here. How many? Three times, what was the mass? The percentage abundance? Good, X. Good. Plus, finally, I have what there? Times what there? 0.1532 minus. Alright, so now you get it. So we have to solve this man here, and that will give us our answer. What? Only atomic mass. Only atomic mass. No, it will not work now. We need mass and abundance. Mass and abundance. Atomic mass. This one is not atomic mass. It's not what you have here. No. You can't use this value. No. Use this one here. Please stop punching. I'm coming, please. Stop punching. So I have 72.64 is equal to this value, please. 14.579206 plus this one here 19.80734683. Please be confirming the answers. Oh, she asked me 3. You're not even okay. This one, please. What do you have? 26.826 8259. Hold on, another 9 again. 9622 plus, please expand this. This times x gives you what there? 72.92346x. Next up, look up please. Next up, plus, I'm to multiply these two. So it means this will multiply this one first. So these two first. What do you have? 11 point. Sorry. 6311 5848. Finally, this m minus s gives you what there? Minus 75.92140 x. So you know what to do here. Collect like terms. Yes, please. 19.807340. Thank you. All right. So 72.64 is equal to, please add up the addables. This one, this one, this one, and this one. Please sum them up. What do you have? Please take your time. Punch correctly. What do you have? Please, I will dump the past questions on the WhatsApp group, on the paid WhatsApp group. So make sure you're there. I'll just show you anyone that I've not done. Please go and make your research. I think you may have tried for today. I wish there was time. If you are willing, me too, I'll sit down here. We'll learn till 8 p.m. And I'm not kidding. Another break. Please, Sam, what do you have? $72.8437 0166. It's not correct. It's not correct. Correct. Please do the x's. What do you have? This one and this one. Do the x's. What do you have? That is this one minus this one. The x is what do you have? Huh? Do the x's now. This one minus this under x. Minus 2.99794 x. All right, let's get x. Move this man over here. I'm having 72.64 minus this one here, 72.84370166 is equal to minus 2.99794 x. So simply take this man over here, becomes negative. That's the concept. So I'm just trying to find x here, no big deal. So subtract this, what do you have? Yes. Yes. Oh. You will not kill me. Oh. You can't kill me. Correct or not correct? Is it correct? Please, somebody punch now and confirm. Is it correct or not correct? It's correct. It's correct. It's correct. Subtract this. What do you have? 0.2037 is equal to alright, so we can easily find x here. To get x, divide here by minus 2.99794, divide here by minus 2.99794. So what's x, please? Give me x there. So x is equal to how many? 0.0. Give me, I need it in 2 dp. Or give me like 4 dp. What do you have? 0.678 94. 0.06. Okay. Look up, please. Give me this in percentage. What will it be? Multiply by 100 from here. 1, 2. So because of there, 6.794%. Also, we said y is equal to what there? 0.15. 15 what? 32 minus x. That's equal to 0.1532 minus x, 0.06794. So y is how many? 0.08526. Give me this in percentage from here. 26. Give me this in percentage here. All right. Now remember that we said x was what there? The percentage abundance of what there? Germanium what? Germanium was it 60, what was the value there? 60 what? 73. And this one was for germanium what there? 76. So therefore, if you're here, therefore the percentage abundance of germanium 73 is 6 point. Please check in the question they gave to you. They gave you percentage abundance in how many dp? So check in the question how many? 2 or 3? 2. So please, I'll convert this to 2. What will it be there? 9 to 2. What do you have there? 5.3. So therefore, the percentage abundance of germanium 73 is 6.79, and the percentage abundance of germanium 76 is 8.53. This is question 3A solution. 3B. All right. Finally, 3B. 3B says ethanol CH3CH2OH is one of the active ingredients in the making of hand sanitizers. Is it correct that ethanol has a mass of 46, question mark, why or why not? So is it correct, yes or no? Why or why not? Let's get molar mass for ethanol, please. Carbon, how many? 12. Hydrogen, 1 times how many? 3 plus carbon, 12 plus hydrogen times 2 atoms plus oxygen, 16 plus hydrogen, 1. This is equal to 12 plus 3 plus 12 plus 2 plus 16 plus 1. This and this 15 plus this 27 plus this 29 plus this what? 45 plus 1, 46. So is it correct, yes or no? Yes. Why? Is it correct? The answer is no. 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 Be very careful. They didn't tell you molar mass, they said mass. They didn't tell you molar mass, they said mass. Ethanol, CH3CH2OH, is one of the active ingredients in the making of hand sanitizer. Is it correct that ethanol has a mass, not molar mass, of 46? The answer is what there? No. Why or why not? Because 46 is the molar mass of ethanol and not the mass. That's the answer. And then you finish and say, I burned the paper. If you see my work, 100/100. Funny. So see how even the easiest of question itself is not that simple. Even the easiest of question is not even that simple. All right. So I think we're done with this one, please.